So gave you all a little spoiler in that last movie in which I mentioned beta decay. Well, beta decay is a situation in which, again, an unstable radioactive nucleus kicks out a particle, in this case a beta particle, to form a new nucleus. What's a beta particle, you ask? Well, it's a particle that has a charge of -1 and a mass of 0. Well, wait a minute, you said. That's an electron. And indeed it is. But in nuclear chemistry, we eschew mention of electrons. It is a beta particle. Now, balance an equation for this. Carbon-14, that is a nucleus that I'm sure you have heard of an awful lot. It is radiocarbon, it's how they date things, although of course in the popular movies and TV they often use carbon-14 to date something that there is no way you could date using carbon-14, but I won't talk about that here. So carbon-14 undergoes beta decay. What's the product nucleus? So we start with carbon-14. It's going to kick out a beta particle, and we ask ourselves, what is left? Well, balancing mass and charge. Mass is 14 on the left-hand side, charge is 6 on the left-hand side. So the mass has to be 14 on the right-hand side. Right now, the beta particle contributes nothing to that, which leaves us with a mass of 14 for the mystery nucleus. Now, looking at the charge, that's more interesting. The charge on the left is 6, so the charge on the right has to be 6. We already have a charge of -1 from the beta particle. So how do we get 6 when we start with -1? The mystery nucleus has to have a charge of 7. So we ask ourselves, what atom has an atomic number of 7? And the answer is N, nitrogen. And of course, we already know the mass of 14. So the particular isotope of nitrogen, nitrogen 14, 14 nitrogen, however you would like to express that. Okay. Now you should notice that we don't have a balance of the protons and neutrons. We start with 6 protons and 8 neutrons. The beta particle doesn't contribute at all, but then when we get to nitrogen 14, we have 7 protons and 7 neutrons. So as I said when discussing alpha particles, sometimes considering protons and neutrons works. There'll be other times, though, in which effectively we turn one into the other. If you look at what was going on here, we've effectively increased the number of protons by 1, and we've decreased the number of neutrons by 1. We have therefore turned a neutron into a proton. Well, if you think about the little balanced equation for that, here is a neutron. If we turn it into a proton, the mass is going to be the same because both neutrons and protons have a mass of 1, but our charge on the left-hand side is 0. Proton's got a charge of +1, so thus the other part of this equation must be something that has a mass of 0 and a charge of -1 in order to balance things out. And of course that is an electron, except we don't call it electrons here, we call it a beta particle. So effectively what goes on for beta decay is that a neutron turns into a proton and an electron expels that electron as a beta particle. Now, how can that happen, you ask yourself? Well, it can't if you're thinking of these as particles, but they are not particles, they are waves. Okay, and if you think of a positive wave and you think of a negative wave in terms of the charge, when you put the positive and the negative wave together, you get a balanced out, cancelled out, destructive interference, as you would call it. So what we're doing with the neutron is we're taking that cancelled out charge and we're splitting it into a positive and a negative wave. Okay, so very hard to think about these things in terms of just the little lumps of neutrons, protons and electrons that we're familiar with, but remember that these things are usually described as waves as well as particulate, so we can certainly think about taking positive and negative waves together. You can also remember that although we don't talk about it in chemistry, when you look at nuclear physics, they actually get smaller than the protons, the neutrons and the electrons. They have these sub-nuclear particles called quarks, or can't remember what the American term is now. I've just been over here too long. But anyway, we're not going to talk about those, but essentially there are bits that make up neutrons, protons and electrons, and you can rearrange those bits, those quarks, in order to explain how you get an electron and a proton from a neutron. We don't really care in this. What we do care about is that when a nucleus, a radioactive nucleus, decays via beta decay, the number of protons increases by 1, the number of neutrons decreases by 1.